So these notes are on solving one variable inequalities, and this should be somewhat of a review because we've actually been solving inequalities for the past week, and it's very similar to solving one variable equations. So actually, under this big idea box, the first thing we're going to write is that we're going to use the same properties of equality that we use when we solve equations to solve inequalities. Use the same properties of equality that we use to solve equations but this time we're going to use them to solve inequalities. Now there's one property of equality that we won't be able to use in the exact same way, so I'm going to say there's with one exception here. And you may already know what that exception is going to be. It has to do with negative numbers. And we're going to get to that a little bit later in the video, but you might be thinking about it already. So then usually when we solve inequalities, we can graph a solution on a number line. So this little chart here is just to kind of remind you that when you're graphing on a number line, for the greater than and the less than symbols, the symbols without the line underneath, you're going to have an open circle on the number. Because the idea is we don't want to include that number in the solution set, so it'll look something like that with our arrows, and you'll shade in one direction. But then if you have the or equal to with the line underneath, so the less than or equal to or greater than or equal to, you're going to use a closed circle when you're graphing. So it will look something roughly like this, or shaded in, because now if it's or equal to, then you do include that number in the solution set. So let's look at a couple of examples. The first example here, we have 5q plus 10 is greater than 20. So I'm going to think about solving this just like I would an equation. So I'm going to subtract 10 from both sides by the subtraction property. I'm just kind of abbreviating. So subtraction property, I'm going to write prop. And then I get 5q is greater than 20. Oh, sorry, not 20. Is greater than 10. From there, I'm going to divide both sides by 5. And I get q is greater than 2. So that was division property. Okay, so now I'm going to show you two different ways of doing your solution. One way is using set notation. So using set notation, I'd say, first I say what type of number q is. So I say q is real with a little vertical line, and then afterwards I say the restriction on q. So q is greater than 2. And then on a number line, I'm putting a mark to represent 2. I'm going to have an open circle because it's not or equal to 2, it's strictly greater than 2. And then I want to shade the direction that is greater than 2, so that's to the right. So that would be graphing the solution set on the number line. In example 2, we have 8y plus 4 is less than or equal to 7y minus 2. So again, I'm just going to treat this like it's an equation and try to get the variables on one side and the numbers on the other. So I'm going to start by subtracting 7y from both sides to get the variables on the left. And I'll get y plus 4 is less than or equal to negative 2. Okay, from there I'm going to subtract 4 over to the right, and I get y is less than or equal to negative 6. So now I have my solution and I want to write it in set notation and on a number line. So in set notation I'm writing y real, y is less than or equal to negative 6. And on a number line I'm marking a negative 6, and since it's the or equal to symbol, the less than or equal to, I'm doing a closed circle on -6, and then I want to shade to the left this time because it's less than or equal to. So I need numbers less than -6. Moving on to example 3, m divided by 3 plus 8 is not equal to 9. So this is not your normal inequality, but I'm going to show you how we can treat it exactly the same. So if I treat this like an equation, first I'd subtract 8 from both sides and get m divided by 3 is not equal to 1. From there, I'd multiply both sides by 3 to cancel out the 3 in the denominator on the left, and I get m is not equal to 3. So when I go to write my solution set in set notation, it's very similar to what we just did. It's going to be m is real, and m does not equal 3. When you think about what this means for the number line, well, m could be anything except for 3. So I want to shade everything except for 3. So I'm going to mark off where 3 is. I'm going to have an open circle because 3 is not in the solution set. And then I'd shade to the right and to the left because it could be more than 3 or less than 3. Now before we move on to example 4, I'd like you to pause the video and try the you-try problem on your own. And then once you're done, you can resume the video and see the final example. So in example 4, we're going to look at what the one exception is to how we can use our properties of equality. So we have -5 times x minus 6 plus 1 is greater than or equal to 7. So I'm going to start this the same way I've been starting my other examples, so I'm trying to get my x value by itself. I see I have some parentheses, so I could think to distribute the -5 into the parentheses. So that would give me -5x. -5 times -6 would be positive 30 plus 2 is greater than or equal to 7. Now, if I want to combine some of my like terms here, I have a 30 and a 2, so I can add those two together and get -5x plus 32 is greater than or equal to 7. I can subtract 32 from both sides. Get -5x is greater than or equal to -25. Now, at this point, if this was a normal equation, the next step would be to divide both sides by -5. And that still is going to be our next step. But there's one thing we have to do here that's different from if it was just an equation. And the thing we're doing here is we're going to say x, and we have x on the left because the -5's cancel, and then on the right hand side we have -25 divided by -5, which becomes +5. But when I go to bring down my inequality sign, I'm going to flip the direction of the sign. So it was a greater than or equal to, and I'm going to turn the direction so it becomes a less than or equal to sign. Okay? And the key is that whenever you're multiplying or dividing by a negative number, you will always flip the direction of the inequality sign. And we're going to explore this a little more in class the next time I see you, so we'll kind of look at why it is that we must do this, but just know that whenever you divide by a negative or multiply by a negative, you're going to flip the direction of the inequality sign. So that concludes these notes, and we'll be practicing tomorrow in class.